Hey everyone, this is Grant with Lincoln Girls Who Code. I'm going to cover several different things in this video, so hopefully it can be a reference to help people who want to kind of get to where we're at in DrRacket at home, if you want to install and get to be able to doing what we're doing in club. And I'm also going to talk about the lesson for this Saturday coming up, which is going to be about conditional expressions, but I'm also going to introduce Racket's Big Bang function, which is really kind of, Big Bang is cool. Big Bang lets us do a lot of cool stuff that like real programs do. So here we go. DrRacket. A lot of kids at club might want to, they've seen that we can change the colors of DrRacket. Right now we have black text on a white background, and you can see that like the parentheses have like a maroon color, and if I define something, well, let's see, numbers have a different color and so on. So the color highlighting and everything just helps us kind of identify parts of code. But we've seen that we can do change the background to black and get different colors, and some people like that. I like that. So I'll show you. And on a Mac, it's the DrRacket menu preferences. On Windows, it'll be in the edit menu, and like right down at the bottom, it'll say preferences. And when you open it up, there's like several different preferences tabs. You go to colors, color schemes, and then this is my version of white on black. And if you're really into it, you can even design your own color schemes. There's a whole manual how to do it. You can actually just you can change things here. So there's a color scheme. You can define a whole color scheme by making a program to do that. But you can just go in here and you can say, I want the background to be this color. This is the basic colors I want things to be. I want to change all of these colors for different parts of the program. There's tons of stuff you can do, and you can customize it as much as you want. That's part of the fun of programming, is customizing and making your stuff like you want it to be. Anyways, okay, so there's that. If you want to change the colors of DrRacket in your environment, you can. You can make it whatever you want it to be. The second thing is we have another teach pack, and if you're just doing this at home, you might have DrRacket open, and it might look something like this. It might say Lang Racket over here, and when you run it, it's actually going to be running a different language, the Racket language. The Racket is actually a family of languages. So Racket lets us write code in lots of different ways. One of the goals of Racket is to be a tool that lets us solve problems with programming in whatever language we choose, even if that means writing a whole new language. Really, programming is about solving problems using different kinds of information and making models and letting the computer do things that we can't really do ourselves because the computer does things really fast. So Racket is just one of the languages. It's the main language, and there's actually many of them. You can kind of see there's this whole other languages. We've been using beginning student, so that's one thing you might want to do is if you start Racket and you see you have Lang Racket here, you want to choose beginning student. And then the other thing you want to do is to install teach packs, which I already have installed, but let's see. Add teach pack here. I'll actually, you can see I have them installed, image and universe. I'm going to clear them. Now I want to add image. This is what we've been learning so far. We've been using this to draw images in Racket. We also want to add the universe teach pack. Oops, sorry. I'm going to add image first, and then I'm going to add another one. The universe is the teach pack that has the Big Bang in it, like I was telling you. And universe lets us animate things. It actually lets us create a universe. Each program is like a world, and Big Bang lets us create many worlds that can talk to each other. We won't get all the way to that in our club, unfortunately. Okay, so now if you look over here, you can see I have the 2 HTTP image teach pack and the universe teach pack installed, and I'm on the beginning student language. Whoops. Oh, here's this book. I don't know how I got here, but How to Design Programs. This is the book I read that taught me programming. It's a great book, and there's a version 2, which is actually part of what I've been teaching in this club. Okay, so last week we learned how to animate something. We had a problem. We had a rectangle. Let's see. Okay, if I have a rectangle like this and I have an image, we were using cat images. Let's see, I can probably get a cat image real quick. Okay, I'm searching for PNGs because they have transparent backgrounds. And I also want to find one that's not too big, so I'm looking at these numbers underneath. Let's see, 400 by 400. Oh, here, this one's good. Okay, I'm gonna click on the picture. Whoops, I didn't want to click on it. So I want to right click on it. I'm gonna do copy image, and then back in DrRacket, I can paste. There we go. Hey, little kitty. Okay. And first we're going to define a variable. So we're going to give a name to this. So we can just talk about it with a word. Define cat. Okay, and we have a background here. Let's see, define background. Oh, that's right. We also learned about defining constants. Constants are part of your world, part of your program that never change. And when we do that in DrRacket, we do it in capital letters just to remind us. It doesn't change the program at all. It just reminds us that, okay, this name cat is always going to be this cat picture. This name background is always going to be a rectangle. And I'm actually going to make it, this one is, I want to make it bigger because this is 200 by 200 about. So I'm going to make this 400, no, I'm going to make it 600 wide. I'm going to make 250 pixels tall. I'm going to make it solid. And I like teal, or no, aqua. Marine. Okay, so I defined cat to be that. I'm going to define the background to be that. Click run. I can type cat. I can type background. Okay, so our challenge last week is we know how to, we used a function called place image to put the cat on the background. So place image takes an image, cat, takes an X position, so let's say 50, and a Y position, let's say 100, and then it takes an image to put it on top of. And put it on top of our background. Okay, so with this one function, we can actually, the challenge last week was using this function, write something that can put this cat image at any place, get this cat image from the left side over to the right side. And the way we solved that was, we know that at x0, the cat will be, let's see, let's find out where it is. Place image cat x0, and we'll just put it at 100 again. That's about the middle. Okay. Cat 0 with x at 0 puts the cat right here. So the reason that is because it's putting the center of the cat image at x0, y100. So that's right about here. And the goal was, okay, if we can write a function that can substitute this value x and give it any number we want, then we can move the cat all the way across. Like if we can do cat 0, then we can do place image cat 100. Just moving across, and the goal is just to get it all the way. So, whoops. Oh, here's another thing I wanted to show you. If you double click a parenthesis, it'll highlight the expression that you want. I just pasted it. Okay, cat's all the way to the side. So we define that function because we notice that if we have this, and we have this, we have this, that's a constant, background is a constant, and this 100 actually never changes, so that could be a constant as well. Let's just define it as cat y and make it 100. So now we see that to do this, to get our cat from one side to the other, we notice that there's only one thing that changes. And that's a perfect place to recognize that we can define a function that captures this pattern by creating a function and a variable. So we want a function called DrawCat. So this is our name. This is just a way to kind of tell other humans about what our function is doing. Its name is DrawCat, and we expect it to take a positive counting number. So it's going to start from 0, 1, 2, 3, 4, 5. Actually, we could just say positive number. I think if it gets decimal numbers, it's fine. So it's going to get one positive number, and it's going to return. The arrow means it's going to create something. The function this function takes one input, and it's going to give us a single output. Kind of like a vending machine. You type in the thing you want, and you always get the thing that you typed in, hopefully. A function will always give you what you ask for. Okay, it's going to return an image. Okay, so to define a function, we type define. And we're not defining a variable. You'll notice there's no parentheses here when we define a variable, a constant or a variable. But when we define a function, we have to make, it's called the function header. We give it the name, DrawCat, and we give it the name of the variable, which in this case stands for a positive number. I guess it can also be 0. Doesn't even have to be a positive number, actually. This has to be a number. Let's just say that. DrawCat will take a number. So let's say X position. And use an abbreviation and just say pause, X pause. Okay, how do we draw a cat at X? Well, let's take what we already have. We know how to draw a cat at X0. Let's just put that in there. And all we need to do is say, okay, this is what our variable gets substituted, is right here. So we'll put X pause there. And you'll notice, since we have the capital letters here, we know these things are things that don't change. They're never going to change in our program. But this lowercase one is something that will change. The value of X pause will change. So we can define this function. And now if I want to, I can say draw, here I'm going to take these away. Actually, yeah, I'll take those away. And I'm going to write DrawCat that will do the same thing. DrawCat 0. DrawCat 100. DrawCat 200. DrawCat 600. Okay, now when I click run, we should see a series of images with the cat going across the screen. Yeah, okay. So it starts at 0, 100, 200, and all the way to 600. Now the neat thing is there's this animate function. And animate is a different kind of function. Animate, if we were to type animate out like this, what it would look like is this. Animate takes a function that takes a number. So I'm going to say it this way. So this arrow is standing for a function. I'm putting it in parentheses so we can all know that it's some function that takes a number and it returns an image. So animate can take any function that can turn a number into an image. So we can write animate DrawCat. Now notice here we're not putting DrawCat in parentheses. So that means we're not trying to call DrawCat. We're not trying to say, hey, DrawCat, do your thing. DrawCat here is actually a piece of data, piece of information. And we see that right here. It's a piece of data that's a function that takes a number. If we put the wrong kind of function here, animate's not going to work. But if we say animate DrawCat, when we run this, you'll see the cat moving across the screen because animate is counting from 0 up until you close this window. When I click X, animate will stop. So animate's been counting. It's probably about 300 right now. It's moving over to about 450X. Now it's getting almost to 600. Now animate's counting higher. It's still going. So our cat's actually still moving over this way right now. Its X position is going higher and higher. And animate won't stop counting until I close this window. Oh look, it tells us how high it counted to. 986. So animate counts 28 times per second. It counts. So it starts at 0, and after 1 second, it's at number 28. So if you want to know how long that went, we could say 986 divided by 28. That was running for about 35 seconds right there. Okay. We can actually see if we can, never mind. So that's what we did last week. And as soon as we got this done, everyone was like, well, how do I make it loop around? I want the cat to keep going, you know, to come back the other way. Or I want it to move up and down, or, you know, Vanessa was like, oh, I want my rabbit's nose to wiggle up and down. And to create any kind of loop like that, we actually need to be able to ask some questions about how many times this has counted or where this image is. We have to know, like, okay, if it's all the way to this side, then we want it to come back over to here where x is 0 again. So in order to do that, we have to use a conditional function. And a conditional function in Racket is something that lets us ask yes or no questions or true or false questions. So I can write something, and it's really easy. Conditional, you write cond. There's also the if. If you've programmed before, you can do an if-then statement. If true, then, well, and here's how you do it in Racket. If true, it's true. Otherwise, false. It's true. So if false. Okay. So if can only do one thing though. Cond is our friend. Cond does lots of stuff. You can ask as many questions as you want. That's cool. So cond, I could say, like, if this is true, it's not going to be true. It's going to be false. Then say, you lied. If this is true, say, you lied again. This is true. You told the truth. So when I run this cond, first it's going to say, is this true? And if it's true, then it's going to tell us this. But this isn't true, so it won't say you lied. Then it's going to ask, is this true? Well, no, it's false. So it won't tell us that you lied again. Is this true? Well, yeah, it is true. So it's going to say, you told the truth. So you told the truth. Now, why is cond good? What would we use cond for? Well, cond lets us ask questions about things like let's say if we want to know a number is even or odd. Define what kind. Here, let's write a little what kind. It's going to take a number, and it's going to return a string. And this is something that takes a number and tells us if it's even or odd. So we need to use cond. And luckily, DrRacket already knows what even and odd is, so I can say even. Oh, I forgot something. What kind takes a number? I'm going to call it num. Even, huh? Num. So I know we want to ask if it's even. I know we want to ask if it's odd. Num. Okay. If it's even, what do I want it to do? I just want to make quotes that says, this number is even. This number is odd. Okay, so I'm going to run the program again. I'm actually going to turn off the animation. Running the program because I want to try out my function I defined. What kind? What kind is 10? What kind is 11? Well, what kind is 0? Even? Then no 0 was even. What about 1/2? Oh. Even expects an integer. So we have to be more careful about what kind of number we give this. We have to say it's an integer. Or we could say, yeah, that's what we can do. Okay, so with this conditional function, running out of steam here, doing this live. Okay. We want to ask about, oh, this is hard. There's actually two things I need to teach. It's not just conditional functions. I need to teach a new kind of data that we haven't talked about yet. I think that will make the most sense for what we're doing, but I feel like I should make another video for that. So let's just do a couple more conditional functions. Let's see, we need to know other things that we can ask. I think there's something we can do like this. We can ask questions about images too. Oh, maybe not. I thought maybe we could ask questions about images. Well, you can ask if something is an image. I don't really know what that would do for us right now. Can't think of a reason why I'd want to ask a question if something is an image. Well, there is one thing I wanted to show. Now, this might be a little bit advanced, but we'll try this anyways. So we can do looping without talking about structures. But basically, if we want to make this cat loop back around after it gets off to this side, we need to know what number will Animate count to when the cat goes off the screen. So let's try to find that out. DrawCat 600. So it's not quite off the screen yet because the center of the cat is at 600. So we need to find out how wide the cat is. Image width cat, 195 pixels. So 600 plus 195 is 795. So draw cat 795. Can't see the cat. Let's try 794. Nope. Let's try 780. So I think there's a little bit of room, like, see, there's room on the left side of that cat. So let's say draw cat 750. Draw cat 700. Draw cat 650. Oh, you know what? We need half of that value. Draw cat 625. There's a better way to figure this out. Draw cat 640. Okay, 650. That's a good number. So every time, if we say, every time Animate counts 650 times, if we then send the cat back over here, maybe that will work. So if we change this to be a conditional function, I'm sorry if this is confusing. I clearly didn't think about this enough before I started doing it, but you know, you gotta be brave. Bravery is important. But we can talk about bravery another time while I try to figure this out. It's hard for me to think about both at the same time. Okay, we want to say if so the way to do a counter, there's a math way to do this. Let's say remainder 650. So this will divide the first number by the second number and give us the remainder, 0. Let's make it 1 higher. Now the remainder is 1. So if you've done division, you remember remainder. Remainder is how much is left over after you divide. So one way to do loops is by using the remainder. This is going to count up. Every time, if x goes up and we keep dividing by 650, the remainder is going to keep going up. So there's only one problem. Animate starts counting at 0. And this is, oh, well, we can do that. We're not dividing by 0. That's great. Okay, so we can use remainder. If remainder is 0, then we want the x position to be 0. That's how we make this loop to happen. If you don't understand that, we can talk about it. It's basically an animation loop. We're saying every time we count to 650, we want to start back over. And the way we can do that with this computer is because the computer doesn't know. It doesn't know what it's counting to. It doesn't know anything. So we have to find a way to do it. So if the remainder of the x position, which is actually time, this is the number of times it's counted. So why don't we change that now that we know what it is? If we divide the time, or let's call it count. If we divide the count that animate is counted to by 650, oh, actually we want to say if that equals 0, and we can do that by saying 0? 0, huh? Like this, I think. Yeah. If that is 0, then we want to place the image at, oh, actually, you know what? We don't even need a conditional statement for this, I think. Let me try something. Making it too complicated. What if we just do this? Let me try that. I don't know if this is going to work, but basically what I'm saying is, oh, this isn't xpos, it's count. Every time, oh, yeah, as this counts up, it's just going to use the remainder of this as the x position. So this is a little funky, but this is going to basically count from 0 to 650 and then start over again. Because as this goes above 651, it's going to go back to 1. Let's see. I think this is going to work. Okay, let's watch our cat go across. I should have made it go faster. That can be a challenge for you, figuring out how to do a little math to make your image go across faster. Okay, it's going across. It's going to disappear in a second. Let's hope. Oh, there it is. All right. Now, just to make sure, I have to see it happen one more time. Then I'll be done. This is a long video. Dum-de-dum-de-dum. Yeah, it works. All right. Oh, we did looping, and we did looping just by knowing a little bit about math, using a trick, a math trick. And we don't actually have to do the math. DrRacket does the math for us. That's the fun part. We don't have to do the calculations. We just get to do the math part. Okay, well, I think I'm going to say goodbye because this is a long video. We're going to learn more about using conditionals to do more kinds of behavior. So, like, what if we want the cat to bounce back and forth? You know, it hits one wall and then starts going back the other way. So we need to learn to do that. We need conditionals, but we also need to ask questions about where this cat is. Right now, the program doesn't know anything about where this cat actually is. The cat is moving based on the number that Animate is counting to. That's all. So we're going to learn about something called a struct, which will tell us something about our world that we're going to create, and use Big Bang to do animations. Big Bang can do more than just animate. Big Bang can respond to keyboard and mouse and video game controllers, and it can talk to the internet, and it can talk to other Big Bang programs, and it can do way more things than I know how to do, and it's awesome. And you could be studying Big Bang from now until you're almost done with college, and maybe even beyond college, and still not know everything about it. It's like our universe. Okay, well, I hope you liked this video. I'm having a lot of fun being part of this Girls Who Code Club, and I'm glad to be here. I'll talk to you later. Bye.